Okay, so here's a video to try to kind of walk you through the homework or the elasticity practice set. If you printed it off, maybe you gave it a try, maybe you haven't tried it yet, you're just going to follow along, either or. The first question is currently the price of peanut butter is $4 per 32-ounce jar, and the market is demanding a quantity of 5,000 jars per day. Price falls to $3 per 32-ounce jar, and the market now demands 7,200 jars per day. What is the price elasticity of demand? So I already have a couple things up here on the screen, and I apologize where I have to write by hand. My handwriting is not very good, especially when I have to write on an iPad. But the top part, notice I went ahead and I pulled out the data you need. Okay, you have to identify what your prices are, your P1, your P2, your Q1, and your Q2. And it says in there currently the price is $4, and then the price falls to $3. So we're going to assume that price is $4 to start with, and then moves to a price 2 of $3. To be 100% honest, it really isn't that important whether you have P1 is 4 and P2 is 3, or P1 is 3 and P2 is 4. What is important is that P1 and Q1 match up. So when the price is $4, the corresponding quantity needs to be 5,000. So if you put in P1 is $4, then Q1 has to be 5,000. If you put P2 as $4, then Q2 would also have to be 5,000. All right. The price and quantity need to match up how they would match up on the demand curve. All right. And I guess, real quick, I could do a quick graph here, a supply and demand curve. So there's your curve, there's your demand curve. I guess I'm just going to draw a demand curve here. If this was a price of $4 right there, we'd be at a quantity of 5,000, and then at $3 right here, we're at a quantity of 7,200. Okay, and so that's just illustrating that idea of price, or change in price causing a change in quantity demanded that we talked about in the last chapter. Once we identify this stuff here, that's usually probably one of the biggest struggles that a lot of my students have, is just identifying those. Then it's just a matter of plugging them into the formula that we find down here, this midpoint formula for price elasticity of demand. So I'm going to come up here, and again, my handwriting will be pretty crappy, and I apologize, but plug in the numbers. So it's 7,200 minus 5,000 over 5,000 plus 7,200 divided by 2 times 100%. Alright, so what we're doing is we're finding the change, okay? The change in demand right here, okay? And then we're dividing it by the midpoint. So we find the midpoint by adding the 2 points together and dividing by 2. If you do that math and simplify it out, you get a 36.07% increase in quantity demand. We're seeing a 36.07% increase in quantity demand. Right. Then if we plug in the price numbers, so $4 and $3 for the lower part of the equation, right, we end up with 3 minus 4 over 4 plus 3 divided by 2. Take that all times 100% to get it into a percent. And if we simplify that out, we end up with a negative 28.57. That's an 8. Again, I apologize about my handwriting. You just have to bear with me here. Oops. And so what hopefully you can see now is, and I apologize, I thought I could, I will here in a second, I guess. I now have my percent change in quantity demanded, which is up here, right? That's the top half of the equation. And my percentage change in price. So I'm going to do a couple things here to get rid of some stuff. Maybe. Maybe not. Well, let's just do this. Let's go ahead and scroll down. Okay. Okay, so if you take the percent change in quantity demanded, that's obviously not correct. It should be the percent change in quantity demand was 36.07%, and the percent change in price, if you notice, I actually have that incorrect. It was a negative 28.57%. Right? And so the whole definition of price elasticity of demand, recall, is price elasticity of demand is the percent change in quantity demanded divided by the percent change in price. So I'm just going to take this 36.07 and divide it by 28.57. And I get an elasticity of negative 1.26. Okay. And so I can revert back to that chart that you find in the text, and that's where we said that anything, if when we look at to define elasticity, what type of elasticity it is, we're going to remove the negative sign or just forget about the negative sign. And if its elasticity is between 0 and 1, so if it's point something, it would be inelastic. If it's exactly 1, it's unit elastic. And then if it's greater than 1, and in this case, from an absolute value standpoint, this would be greater than 1, we would say that peanut butter at this price has elastic demand. Okay. On problem number 2, says if Apple knows that its iPhone 6 has a price elasticity of demand of negative 1.35 and it's pondering increasing its price by 12%, what can it expect to happen to quantity demanded? This one, students a lot of times kind of struggle with it, and I don't really know why, because if you look up here, I've got the price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. Right? Well, I'm telling you that the price elasticity of demand is negative 1.35. Right? And we know that then that equals percentage change in quantity demanded divided by the percentage change in price. We don't know what the percentage change in quantity demanded is, but we do know that the price is going to go up, so it would be a positive 12%. What we don't know is what quantity demanded would be, or the change in quantity demand is going to be. So we need to solve for x. So if you recall, solving for x, we multiply both sides by 12%. That's going to cancel out here. We flip the sides around, we get x equals negative 1.35 times 12%, and we can do that calculation, and then the percent change in quantity demanded is equal to, it's going to be equal to negative 16.2%. So what we're saying here is when the price of the iPhone drops by 12, or excuse me, increases by 12%, we could expect to see quantity demand go up, or excuse me, go down by 16.2%. All right, and that's that idea of that demand has a negative relationship. So if price is going up, quantity demand is going down. If price is going down, quantity demanded is going up. And as you can tell, and it's been mentioned already, it's always mentioned in just about all my classes, this stuff can get a little bit confusing. I even screw up when I'm talking about it, and I teach this twice a day, face to face, every semester, and yet it's just sometimes the words come out wrong, sometimes the way we think about it is wrong. So you gotta slow your brain down, or slow your mind down, and focus on what's going on. We're going to go ahead and look at number 3 while we're on this one, because then number 3 says it in the question above, if Apple knows that it has an elasticity of negative 1.35, what type of elasticity is that? Remember, when we remove the negative sign, we just look at elasticities from an absolute value. Anything above 1 is going to be elastic. Okay, so it's got elastic demand. And then the second part is, if its goal is to increase revenues, what should it do to the price? The very end of the text in the chapter 5 reading, it says if you want to raise revenues and you have elastic demand, okay, to increase revenues with elastic demand, you actually have to decrease price. Okay, and the reason is when we dropped price here, or we increased price by 12%, we actually saw a resulting even larger drop in demand, or quantity demanded. And so you're looking at which one is bigger, is essentially what the takeaway is from elasticity. If the change in price is bigger than the change in quantity demanded, then the demand is inelastic. And that means if you have inelastic demand and you want to raise total revenues, you actually need to raise your price. Okay, number 4 is kind of a quick question. What happens to the price elasticity of demand for snow shovels the night before a big snowstorm is forecast to hit a city? What we're trying to think about is, does demand become more elastic or more inelastic? And the whole definition is a product with elastic demand will be very price sensitive. What we mean by that is people really pay attention to the price. Okay, inelastic demand illustrates a product that is less price sensitive. Okay, and so the common one that we use in the text and that I use in class all the time is gas tends to be inelastic or have inelastic demand. Most of us will continue to buy gas because we need to get from our homes to work, to the schools, to wherever our kids go to daycare, wherever our driving is set by other things outside of just the price. Typically we go ahead and pay the higher price and then we just complain about it. All right. So what we're looking at in this question, in number 4, is what happens to that elasticity of demand for snow shovels right before a big snowstorm. If you are facing a big snowstorm and you don't have a shovel and you're going to need to be able to get out in the morning, you're probably not really going to care about price of snow shovels that night. So if you got to go drive around Lowe's and Home Depot, you're really not going to be that price conscientious. You're just going to go to the first place, get a shovel, and then get home. And so number 4, we would say that it becomes more inelastic. It doesn't necessarily mean that it is inelastic, it just becomes more inelastic. Okay. Number 5 says if the price of a new car falls, what will happen to the demand for used cars? Okay, and then it says to explain. If we stop and think about that for just a little bit, price of new cars falls. All right. Odds are, if the price of new cars goes down, quantity demanded for new cars is going to go up. That's the law of demand. So price of a new car goes down, quantity demanded is going to go up. Since new cars would be a substitute for old cars or for used cars, right, we would assume that on the demand curve here, if this was the original demand for used cars, and more people are now buying more and more new cars, okay, we would assume that the demand curve would actually shift to the left, okay. And so that's going back to a question from a previous chapter. I kind of just threw it in to see if people could catch on to see if they remembered what we talked about. Number 5 is a little, excuse me, this is number 6, I guess. I should erase that. It looks pretty crappy. Well, this is number 6. Using new technology, and I'm still not very good at it yet. What we're looking at with number 6 is price of bologna is currently $1.75 a pound. Tim currently consumes 2 pounds of bologna per week. Tim's income increases by 15%, and Tim decreases his consumption of bologna to 1 pound of bologna per week. For Tim, what type of a good is bologna? Alright, what is the income elasticity of demand? Let's calculate income elasticity of demand first. So I put the formula there. Now we're looking at the percentage change in quantity demanded divided by percentage change in income. We already know the percentage change in income is a positive 15% because it says Tim's income increases by 15%. So we just have to figure out the percent change in quantity demanded, and we're going to use the midpoint formula, the same formula we used when we calculated price elasticity of demand. And so that's going to be Q2, which in this case is 1, minus Q1, which is 2, over 2 plus 1 divided by 2 times 100%. Simplified down becomes negative 1 over 1.5, which converted to a percent is 66.67%, and that is a negative 66.67%. So to get the income elasticity of demand, you take 66.67%, it's negative, divide it by a 15% increase in income, and you get something like negative 4.44 as your income elasticity of demand. Basically it's saying bologna is very elastic with respect to price, with respect to income. Income falls by 15%, or increases by 15%, and we decrease consumption of bologna by a bunch, by 2/3 according to the midpoint formula. The reason we use the midpoint, if you stop and look at that, a lot of people will say, we didn't decrease consumption by 2/3, we decreased it by half. You're right, we decreased it by half, we're going from 2 to 1, but on the flip side, if we go from 1 to 2, we increased it by 200%. Alright, and so there's a discrepancy between which way you're moving from, and so the answer, or the workaround around that, is to use the midpoint, and then that way, whether you're going from 1 to 2 or 2 to 1, the midpoint formula will always be the same, in case you're wondering. What type of a good is bologna? If you stop and think about that, since income is increasing and quantity is decreasing, we said that when income goes up and quantity demand goes down, that would be an inferior good. Okay, so when it's a negative, right, that means one's going up, the other one's going down. It's an inferior good. If income elasticity of demand is positive, then we would say it's a normal good. Okay, number 7 can be a little bit tricky sometimes. Um, what the question actually asks, assuming the U.S. tea and coffee are substitutes, currently tea is priced at $1.85 a pound, and the U.S. population consumes 200,000 pounds per day, while coffee is priced at $1.95, and the U.S. population consumes 425,000 pounds per day. Suppose the price of tea drops to $1.55 due to an influx of tea from the Mediterranean Sea region, and consumption rises to 255,000 pounds per day, while coffee consumption falls by 45,000 pounds per day. But the price of coffee remains the same. What is the cross-price elasticity of demand for coffee? All right, so there's a lot of stuff there, and one of the first things you got to do is get rid of the information you don't need. All right, if we're looking at the cross-price elasticity of demand for coffee, that means we are measuring the percentage change in quantity demanded of coffee divided by the percentage change in the price of tea. All right, and so first I'm looking at changes in price of tea, so I got to look at tea prices. Notice originally tea is priced at $1.85, and then tea drops to $1.55. When tea is priced at $1.85, notice the U.S. population consumes 425,000 pounds of coffee. All right. A lot of times I have students try to use that 200,000 pounds, but that's the amount of tea they consume. And so we're looking at cross-price elasticity of demand for coffee. We don't care about the price of coffee or the quantity demanded of tea. We're worried about quantity demanded of coffee and the price of tea. When the price of tea drops to $1.55, we cut consumption by 45,000. That doesn't mean we now only consume 45,000. We've just now cut consumption to 380,000. So then we go and plug those numbers into the midpoint formula. I'm not going to do that. I'm just going to tell you what the percentage changes in quantity demanded and the percentage change in the price of tea are. Okay, so the answers I get, the percentage change in quantity of coffee winds up being a decrease of 11.18%, and the percentage change in price of tea winds up being a negative 17.65%. And if I do that calculation, the cross-price elasticity of demand for coffee with respect to tea is 0.63, which would be inelastic cross-price elasticity. All right. If you want to know what type of a good they are, then if you think about what's going on, the price of tea here is decreasing by 17.65%, which should, in theory, mean people will buy more tea since it's now cheaper. If they're going to buy more tea, they drink less coffee, and so quantity demanded of coffee falls as well. Whenever we see a positive income elasticity of demand, I just noticed I wrote CPED here, and it should have been income elasticity. Whenever we see a positive income elasticity of demand, that is indicative of a normal good. When we see a negative income elasticity of demand, that would be an inferior product. Okay. Number 8 says the price elasticity of supply for oil is currently fairly inelastic. Explain why this might be. One of the reasons we talk about supply elasticities being inelastic. Inelastic means we don't respond much to a change in price. Okay, and the reason the oil market tends to have inelastic supply, or fairly inelastic to start off with, is the fact that it takes a long time to gear up for the kind of production that we needed to increase supply. If you think back to when oil prices really took off in 2007, 2008, there was a pretty big run-up in oil prices. And that was for a lot of reasons. Demand was high, and we were starting to notice some hiccups in supply. Price went really high. it had to stay pretty high for a good 2 or 3 years before oil companies even got interested in investing in new technologies, new drilling technologies, new drilling leases, that type of stuff. The oil business is a long-term business. It's not something that you just get in, hope you make some money, and get out of in a few months. And so anytime we see a business with that type of long-term mentality, it generally takes a while for the supply to respond to price increases. Okay, and so price elasticity of supply for oil is fairly inelastic. Price might have went up. Okay, and a lot of times, if we look at just a standard demand curve or supply and demand curve, the demand is here. Okay, the supply is here, and if supply shifts, or we let's say demand, shifts to the right. Okay, so we see a shift to the right of demand. So we had our original demand, and now we have demand 2. Okay, theoretically, that just pushed price higher. Okay, we're at a much higher price at this point than we are here. Okay, so we see a shift in demand, but it causes a change in quantity supplied. We're going to be supplying more to the market at that new higher price. Okay, it's going to be tough for supply to respond now, though. We're not really going to see supply really increase much. We're not going to see a shift to the right of the supply curve for a while, because it takes time to put those resources into place. All right, and so the more time it takes to put those resources into place, the harder it's going to be to actually see supply start to increase on that type of stuff. That's why when hydraulic fracturing and horizontal drilling were introduced, that had an effect on the supply of the oil market. Okay? It didn't have an effect on demand, it had an effect on supply. I put B in a perfect world if that were the only change in the oil market. Okay, so I'm going to try to get rid of all of this stuff here. Actually, I think I can do this. Okay. If I go back and draw a demand curve, okay, and so you got demand, meant to do that in red, sorry. You've got a supply curve here. If the only thing that changed was an increase in supply, right, we would assume that we would see a lower price. Okay, that's what should happen. Okay, if supply is the only thing, we should decrease price. The reason we didn't see that over the last several years is at the same time we were starting to increase supply, we saw the demand curve shifting out. Right. Maybe not so much in the U.S. We might not have been buying as much oil in the U.S., but worldwide we were starting to buy quite a bit more, thanks China and India. And then the last one, if we knew the price elasticity of demand for oil was negative 0.7, we saw a 15% decrease in the price of oil. What would happen to demand? Okay, so we're looking at price elasticity of demand here. We're saying price elasticity of demand is negative 0.7. We see a 15% decrease in the price of oil. We don't know what the percentage change in quantity demanded is going to be, so we need to calculate it. Multiply both sides by negative 15%. It's going to cross that out. X is going to be equal to negative 0.7 times negative 15%. And so the percent change in quantity demanded is going to be equal to negative 4 point, excuse me, it's not negative, positive 4.66. Okay. And I'm looking at that incorrectly, and I don't know why I can't erase it. This is starting to, it's not 4.66%. The percentage change in quantity demanded is 10.5%. That's a positive. Right? Price goes down 15%. We only demand about 10.5% more. And that's, like I said, something other than the price typically dictates the amount of miles that we drive. Okay, the last few we're going to kind of go through pretty quickly and probably on the same slide here. Number 9, price elasticity of supply for corn is currently 0.85, and the price of corn decreases 20%. What can we expect will be the percentage change in corn supply this year? So again, now we're just doing price elasticity of supply. That is the percent change in quantity supplied divided by the percent change in price. Okay. Here we know that the PES is 0.85. We don't know what the percent change in quantity supplied is, but we know that price decreases by 20%. Alright, so we're going to solve for x again, so we multiply both sides by negative 20%. Crosses out. X equals 0.85 times 20%, and so the percent change in quantity demanded is going to be equal to 17%. Again, that's inelastic supply because we're changing price by 20%. We're decreasing price by 20%, and that is a negative 2, by the way. We see a decrease in supply of 17%. Crops tend to have fairly inelastic supply. Grains, cattle, those types of agricultural commodities, because they take at least a year for supply to change. Supply is kind of fixed. It's based on the weather and the amount of the crop that gets planted. And so if price should decrease this year, farmers will plant less of it next year, and it takes a little time for it to work its way through the system. Number 10 looks at the cross price elasticity for Coke with respect to Pepsi. So now we're looking at the cross price elasticity of demand. We're looking at the percentage change in quantity demanded of Coke divided by the percentage change in price of Pepsi. Okay. And so we look at this, it says we've got a 1.15 cross price elasticity. Again, we don't know what the demand for Coke is doing, but we know that Pepsi decreases by 5%. We're going to solve for x. X winds up equaling negative 5.75%. We see a 5% decrease in Pepsi. Means Pepsi is now cheaper. More people are going to switch to purchasing Coke. Okay. More people are going to switch to purchasing Pepsi, which is going to drive the quantity demanded of Coke down. I got too many things I'm thinking about, and I apologize. I might even be confusing you more here. Would you expect the income elasticity of a new car to be positive or negative? Okay. So this is looking at income, and so now we've got to make a decision. All right, are we looking at a normal good or an inferior good? Well, new cars tend to be normal goods. As we have more money, we buy more of them. Okay, and so if we assume that a new car is a normal good, and that means as income goes up, so does demand. That means a positive, both are moving up. So we would assume that new cars would have a positive income elasticity. Number 12 asked, would you expect the price elasticity of demand for a new car to be elastic, inelastic, or unit elastic? Since cars are usually high priced, they represent a very large portion of our budget, and the more of our budget they represent, the more elastic demand is. And the last one, number 13, would you expect price elasticity of demand for home insulation to be more elastic or more inelastic in the winter months? you aren't really concerned about price at that point. You're more concerned about getting your home insulated if it's cold and drafty or colder than it normally is. So in the winter time, okay, we find products for keeping your home warm to be more inelastic. Hopefully that kind of helps. We'll call that a day. If you got any questions, let me know. Thank you. Have a good day.